at examples, and then this will be shared with you afterwards on the chat, as well as I will share a link of a recording with you as well. And then what I will also do is on the Western Cape channel, there will also be a recording for you later tomorrow. Okay, so let's just basically continue off where we ended last week, and then tomorrow we will have our last session. Okay, so also please, if there's any questions that you guys have, I will add all of them into a session for tomorrow, that we can round off with any questions. So the ones that have been asked in the chat, was one or two, so I will add all of them into a presentation for tomorrow. Okay, so let's start just going through these ones, and then a next set to tomorrow night as well. Okay, so simplification. So we've got the multiply, so we are allowed to simplify by cancelling out what's on top and what is below. So that is allowed. So 3 goes into 3 once, 3 goes into 6 twice. Oh, sorry, there is, I thought everything was multiplication. I did not see that. So, sorry, we're not allowed to do it. Okay, so let's first see how many terms there are. Top one, here we have one that is actually 2 terms, so it's 2ab to the power of 2 plus 4ab, and at that side, okay, so that's a bit of a different story. So let's quickly, what I would do is to say, let's first simplify across the board. So there's nothing with 3a to the power of 2b that we can simplify, but here we can simplify, and there's a 2 that we can take out of both. We will be left with 1 and 2. Let's make that bracket a bit. We'll check now how our bracket will pan out. There is an A in both, so we can have an A in both. There is 1b, 2b, so there's 2 in both. But that is basically. And so let's just check if we have that. If I multiply out, so that multiply in gives you 2ab to the power of 2. Multiply that in, it gives you 2 4ab. Okay, so that at least we have. And then that will also be able to work out. It will be b plus 2 times b plus 2. If we factorize that, let's just quickly check it out. B plus 2, so b times b is b to the power of 2. B times that one is plus 2b. that times that is plus 2b. So that would have been with plus 4b, and 2 times 2 is plus 4. Okay, so let's just factorize. I don't know if that will help us anything at all, but now at least at the bottom we've got 682b5. Okay, now you see everything above is multiplication, everything below is multiplication. Now we are allowed to simplify. Okay, so here is a b plus 2 at the bottom. There is a b plus 2, so those two can cancel out. Now we can say 3 goes into 3 once, 3 goes into 6 twice. So at the bottom, we're going to sit with 2 times 2, which is 4. At the top, I'm going to sit with 1 times that. But let's just check. At the top, we're not sure yet. There's a 4, so it can be that one. There's a 4. There's a 4. There's a 4. Okay. Could not have eliminated anything yet. Okay, but let's just make 100% sure what we have now taken out. So that is out of the equation. That is out of the equation. That is out. And that is out. Okay. So let's see what can we still eliminate. A2 at the top. A2 at the bottom. B at the top. B at the bottom. So at least we can say at the top, what's left is b plus 2 in brackets. Okay, so now we can check b plus 2, b plus 4, no, 3b plus 4, no, 3b plus 2, no. And what's left at the bottom, we said it's the 4. Then there's A. Okay, sorry, that should have been B3. I've written it down as B2, sorry, so that, let's just quickly now see, I cancelled 1b out, so there's still 2 b's left. So 4b at the bottom, 4a, b2, b5, so 5 minus 2 is b to the, wait, now let's quickly just do those b's over. We now make it something that's incorrect, correct? Let me, while you are on the link, or let me quickly in the chat share it. That's weird that you can get access to the chat, but not the meeting link. So check if the meeting link will work now. Okay, so let's just quickly. So we've cancelled those two out. There was b plus 2 left. We cancelled that out. So that was also b to a power of 5. Okay, so a plus b is what I want. Sorry, I'm now worried about these answers. Is b2, b, because I now get b's to a power of 3. So let's just, while we are now doing it, I'm going to redo it. Because it felt to me that I did not get any of the answers. So let us quickly redo it. Okay, so we've got 3a to b 3. Let's just make sure 3a to b 3. And at the top, we've got, that is going to be b plus 2 times, yeah, I quickly just want to check because when I had that extra b left, so I just want to make 100% sure that I did write everything. Okay, so at the bottom we've got 2ab, and what's left is b plus 2, and on this side is 6a to b 5. Okay, so let's take another color. That and that cancels out. A2 cancels out. B3, that cancels out. So what's left is 2, because 5 minus 3 is 2. So at the top, we can still, 3 goes into 3 once, 3 goes into 6 twice. Okay, so at the top, I've got b plus 2. And at the bottom, I've got 2a, b, so it's 2 times 2 is 4. It's 1a, b, b3. I say what? Let's just quickly, is that what, as you guys now went through that as well, is that what you got? Oh, it's 2ab, 2a times 2 is 4ab3. So yes, and does not, so that should probably have been 3 because that's the closest. Okay, so none of these are actually correct. Okay, so let's just none of them are actually correct. Okay, so if something like this happens in the exam, just afterwards, send me a WhatsApp or email to say there was a question like this that just it did not work out, so that we just make 100% sure that there isn't something like this creeping into your questions. Okay, now I'm hoping this one is correct because this is quite a, a bigger question to work out and to work with. Okay, so again, simplification. And let's see if I can just actually make this a bit bigger. Okay, so let's look at this. We sit with 1 plus 1 over x plus 1, x minus 4 divided by x. Okay, and then we see everything nearly, there's not going to be a wonderful number that we just can cancel out. So in the end, we will sit with something that is not just single numbers. So let's look at something like this. Okay, so the first thing I would have done if I get something like this is to, for the top part, to say, okay, let's get a lowest common factor, or let's just see if we can make sure everything is on top of x plus 1. Okay, so if we sit with 1, the easiest to say then is x plus 1 over x plus 1. That is 1. So x plus 1 over x plus 1 is 1. And then we have the x plus 1, so we can just say plus 1. So the top one, a bit more easier to say, okay, let's try to simplify. We'll simplify it now further, but this is the first one that we nearly try to simplify. So if we put x plus 1 at the bottom of that, we know that x plus 1 divided by x plus 1. So if we only look at this section, x plus 1 divided by x plus 1, that will give us 1. And then if we look at the other section, we basically sit with 1 over x plus 1, which is that. So for this component, it is fine. We've done that. So now let's look at the bottom part. So the bottom part is x minus 4 over x. Okay, so again, what I will do is to say, okay, let's put everything on x. Hopefully that will at least start to make it simpler, but probably not. So if we want to put x over x, so that we can say x squared. So x divided by x will give us, if you have x to the power of 2 divided by x, remember that's x1, the 1 take away 2 minus that 1. So we will be left with x. So x to the power of 2 divided by x will give us the x. And then on this side, we are fine. We have minus 4. Okay, so this still doesn't really, it's not that great yet, because we still sit now with those, and we still don't have nearly an answer for that. So let's continue with the making it a bit simpler. I just want to take that to that side, but it's still there. Okay, so let's look at what the next step is. So let's simplify the top. So at the top, we now have x plus 1 plus 1. So we actually have x plus 2 over x plus 1. Okay, so there at least we start seeing a x plus 2. Okay. Then if we factorize this, x to the power minus 4, that will be x minus 2 x plus 2. Okay, so that will be, if we factorize that, so now we sit with x x minus 2 x plus 2 over x. So, okay, still not really what we wanted, but that at least is a bit simpler. Okay, so what do we do now? Okay, so let's, and we should have actually done that from the start. Let's just rewrite that. So that, so we've got that. That's a 1. That's a second one. Divide by and so then if we have that, we can actually swap it around when we multiply. Just hope there is an answer this time. And now let's see what can be cancelled out. X plus 2, x plus 2. So that's all that cancels out. So we've got x over x plus 1, x minus 2. X plus 1, x minus 2. Okay, so sure, not a quick one, not an easy one, quite a lot of work that we needed to do in this one. So you could have initially also started off with that, but then just remember, if we start too early, you might forget that we need to get nearly it as a fraction. So I normally don't want to, at this point, say divide by and then the other one, because then I might not go this route where I can simplify and get the necessary information that I need. Okay, so again, not an easy one that one can just quickly eliminate. So I have included a few of these difficult ones tonight so that we can just make 100% sure if you guys get something like that on Thursday, that we are prepared for it. Okay. Again, the session is recorded, so I will share the recording after this session on our WhatsApp group, and then I will also share. It will be shared into the my Unisa platform a bit later as well. Okay. Okay, so let's look at something like this as well. Okay, so this time there is a fraction number, so we know that we will need to nearly simplify and see what we get in the end. So let's first do the brackets. So we sit with 2 minus 4 times, so when it's a bracket, it's minus 1 times 2. So at the top we sit with 2 minus 4 times 2 minus 2. So at the top we will, in this instance, sit with 2 to the power of minus 6. Let's just see if we have something to divide by. 2 to the power of 0 is 1. 1 plus 1 is 2. 2 to the power of minus 1. Okay, so 2 to the power of minus 1. So we can now nearly decide, do you want to take 1, 2 up, or do you want to bring all of this down? So since everything is in fractions, I would just say, okay, we've got the 2 minus 1. Let's bring the minus 6 down. So if we bring the minus 6 down, at the bottom, it becomes positive 6. So we have a fraction of 1 over 2 to the power of 5. And then I don't have the faintest idea what 2 to the power of 5 is, so I will use my calculator to work that out. But 2 to the power of 5 is 32. And the problem now is 2 to the power of 6 is 64. And if we made that minus 6 and set minus 7, we get the 128 as well. So nearly for all of the other ones that we could have set, it is in the end 2 to the power of minus 5, minus 6, or minus 7. There is an answer for us. Okay, so just be very careful in this instance that when you bring it down and you swap it, that we are using the right numbers, because yeah, there is, if you set 1 or 2 to the power of minus 6, because you maybe have said this is everything is just 1, you would have gotten 1 over 64. And if you brought that down and you said it is minus 1 minus 6 to get minus 7, then you would have gotten that one. So just be careful with this one if you get something like that, to make 100% sure when you cancel out you get the right one. Okay, I think this is the last of the simplification questions. So what I'll do first normally is I simplify within the bracket when I see something like this. So let's simplify within bracket, a to the power of 2 at the top, a to the power of 3, so we've got one more at the bottom. So it's a to the power 1 at the bottom. And let's rather otherwise make it a different way to cancel out so that people can still see on the recording. Okay, so we've done with that. So we know now at the bottom there is going to be a A. So yes, that might be, not be, might be, might be. Okay, so one of them already cancelled out. So let's see B minus 1 at the top, B minus 2. So at the bottom, we've got a B minus 1 more. Okay, so B minus can still turn upside down, so that's fine. So we've got the B's sorted out, and then, oh, there isn't a C, so at the top, C to the power of 3. So we've got a C at the top. Okay, sorry, nothing yet, but further we can cancel out. So now we take the outside of a bracket, so C3 to the power of 2 is C6. It's 3 times 2. Okay, so we see it's C6. Then A1 to the power of 2 is A2. B minus 1 to the power of 2 is B minus 2. Okay, we don't see any B minuses 2. So again, B minus 2 at the bottom. If we take it to the top, a minus becomes a positive. So we sit with 2 for B to the power of 2, 6 to the power, C to the power of 6 over A to the power of 2. So let's quickly see B to the power of 2, C to the power of 6 divided by A to the power of 2. Okay, so bottom factors is basically what, so let's do something like this. 1 over a is a to the power of minus 1. Okay, so if I then say 1 over a to the power of minus 1, if that one is to the power, if 1 over a is equal to a minus 1, 1 over a minus 1, okay, so I'm now going to confuse you more. So let's quickly do it with numbers. I think it's sometimes easier to see it with numbers. Okay, so let's say 1 over 2, if we need to write it in a factorial, or sorry, in a something to the exponent, it would have been 2 to the power of minus 1. Okay, so if we say 1 divided by 2 to the power of 1, so work that out on your calculator. So 1 divided by 1 over 5. It should then give you 2. Okay, so and the other thing nearly, I'll get to the hand now, is when you have the bottom factor, if it is purely a positive, so if it is a over b, and you want to write it without being a factor, the a is at the top, which is positive. The b you can take to the top, but then you need to make it a minus 1. Okay, so, but then the same you can do the other way around. So if you wanted to, if you had a b minus 1 and you wanted to write it as a factor, you can write it as a, take the b, because this is now over 1, take the b to the bottom, and the b minus 1 becomes positive b plus 1, and b plus 1 is just b1, which is b. Okay, so don't know if that really helps, but that is a way nearly to do it. So what I normally do, and if there wasn't now a 2, what I would have done automatically is, if I had that c to the power of 3, b minus 2, and there wasn't anything where, I would have automatically rewritten it as, and bring that to the top to say b to the power of 2. Okay, because when it goes to the top, it changes the signage. The hand, yes.
Sorry, can I quickly ask me? I
Yes,
see that power of 2 affected all the variables, even the
yes,
8 power 3. So I want to know if there was a coefficient, was it also going to affect the number?
yes, yes,
Okay.
yes. So if there was a 2 there or a 3 there, it would have impacted that as well. Okay, so as long as if it was in front of it, no. If it was inside the bracket, yes. So be careful in the exam if they do this. So let's just, and let's make it, so if I do, so if I do this in the exam, and if I do, okay, so if we have the top one, we will first do what's in the brackets. So it is A2 times 2, it's A4. Then it is B4, 4 times 2 is 8. And that will be 3A to the power of 4B to the power of 8. If it is within the bracket, now that is 3 to the power of 2, which is 9. Again, then A2 times 2 is A4. B4 times 2 is 8. Okay, so then there is just that slight change. So just be careful where that number is. If it is within the bracket, you need to remember that you need to multiply that with itself as well. If it is outside the bracket, not. Okay. Does that help a
Okay,
bit? Cool. Okay, so let's look at the next one. Okay, so this again was it seems strange, and that's why I thought to include it as well. One can nearly look at this and say, okay, the answer is 3. So if I look at this, whatever that is to get 3, okay, so nearly, what must I square root to get 3? Okay, so if I say 3 to the power of 2, that will be that I will need to square root, which is 9. So that I could have said, okay, that answer must be equal to 9. Okay, so let's nearly follow the principle to say, okay, but I need to, and let's put that in brackets. So on the one side is the square root, and the other side it's, okay, so to get rid of the square root, I would have said that whole thing to the power of 2, because then the square root falls away. And how do we know that? So if we've rewritten that component under the square root, that would have been the same to write it as, so that and that is exactly the same. Okay, so the root of 2x plus 5 is the same to say 2x plus 5 to the power of a half. And so then if we did this on both sides, that and that on the left-hand side will cancel out, so that we sit with 2x plus 5 to the power of 1, but 2x plus 5 to the power of 1 is just 2x. And then on our right-hand side, 3 to the power of 2 is 9. So 2x is equal to, that goes over to that side, is equal to 4. So x is equal to 2. I will always check my answer just to, so if I say x is 2, 2 times 2 is 4, 4 plus 5 is 9. The square or the root of 9 is 3. Okay, so we know that is correct. If you did not know what to do, and a lot of these questions is sometimes, so it's, we can't really, with any of these, go and say substitute. But with this one, in the exam, one does just, there's some questions I know out of experience that you just totally a blank on what to do. In this instance, because they give you an X, what you can do, it's not against the rules, it's not against, you can just go and say, well, let's put the 4 in. 2 times 4 is 8. 8 plus 5 is 13. The square of 13, not 3. Okay, cool, not that one. Let's put minus 2 in. Minus 2 times 2 is minus 4. Minus 4 plus 5 is 1. Square root of, or the root of 1, ugh, not 3. Let's put in 2. 2 times 2 is 4, plus 5 is 9. Root of that, great, it works out. You can even try the last one and say, okay, minus 1 times 2 is minus 2. Minus 2 plus 5 is 3. Okay, the root of 3 is definitely not 3. So that cancels out as well, or it's not 1. So wherever they give you x is equal to, you can always replace it in the original formula to see if it works. So there's if at these, and I think the next one is also, so if you at a point is just totally blank on what you need to do, there's always a way that for all the things that they say x is equal to a number, you can always go and, yes, it will now take some time to go through all 4 options to put it into the question, but at least there is a way to do it. Okay, so let's look at the next one. So here they ask us to again solve for x. They give us everything on fractions. So the first thing we will need to do nearly is to get your lowest common multiple, or basically your lowest common fraction that you're going to work with. Okay, so let's just look at some of these. Okay, so let's just quickly rewrite this over. We've got 2x minus 1 divided by 4 minus 2x over 3. That is equal to 4 minus 3x over 12. Okay, so we could have said, let's simplify, but because we're working with a 4 and a 3, 4 times 3 gives us 12. So I would just automatically first go and say, okay, let's put everything on 12, because then we are working with an easier number. So 4 goes into 12 3 times. 3 times 2 is 6x minus 1. We can simplify that now. 3 goes into 12 4 times. 4 times that is 4 times 2 is 8x. And on the other side, we stay with 4 minus 3x, because 12 is 12. So now, because everything is on 12, we can rewrite it as 6 is times x minus 1 minus 8x is equal to 4 minus 3x. So we've got 6x minus 6 minus 8x equal to 4 minus 3x. So let's bring all the x's to this side. We've got 6x minus 8x. That becomes the minus 3x on the left-hand side becomes plus 3x. And then all the numbers to the right-hand side. So minus 6 becomes plus 6 plus 4. So on this side, we've got 6x minus 8x, so that is minus 2x plus 3x. That means that we've got x is equal to 6 plus 4, which is 10. Okay, which is option 2. So you can also test it a bit. So if you put in 10, 10 minus 1 is 9. 9 divided by 4, and let's put it in the calculator. 9 divided by 4 is 2.25. If we times it by 2, that will be 4.5. Minus, again, 10 in there. 2 times 10. Now we're going into fractions, but that's fine. It's 20 divided by 3 is 6.67. So that is basically 2/3. But let's put it in there as well. 4 minus, okay, so 10 into the x, so 4 minus 30 divided by 12. That will need to give us minus 2,167. So if you say 4.5 minus 6.7 minus 6.67, we get minus 2.17 is equal to, and we round that off, 2.17. So yes, not very nice numbers that we deal with in the end if we want to test it, but we can still test the answer if we put back the 10 into that original. Okay, again, if we did not work it out, we wanted to test then with 10, at least the second one, it's only 2 types of, but it does take in a bit more time to get to an answer to nearly guess if you don't work out the process. Okay, so this one also, so the questions tonight, I think it is more on the difficult side to some of the previous ones. So I just want to make 100% sure that we cover a lot of the examples from either side to nearly make sure that you see enough examples that might be in an exam. Okay,
Sorry,
so
sir.
that, yes,
I've been trying to reach out to you in terms of accessing the QMI material. I
yes,
think you keep forgetting, sir.
I am. I let me quickly check. Was that the email the WhatsApp that you sent me with the email address?
Yes, sir.
Okay, so I am going to WhatsApp it to you. Some of the material I can't get sent because it's too big. Okay, so
Oh,
I'm gonna send it to your WhatsApp if that is fine with you.
I think whichever way, sir.
Okay.
I do have internet at home.
Okay, cool. Okay, do you have internet somewhere else as well when I send it that doesn't eat
Yeah.
up all your data?
No, I use uncapped, so
Okay, cool.
which
Okay,
okay.
perfect. Then I'll send it to you on WhatsApp.
Okay, I'd appreciate
Because
that.
the email doesn't allow me to send all those files that are a bit bigger.
Oh, okay.
So
Okay.
I'll do that tonight for you.
Okay, I would appreciate that. Thank you so
Cool.
much. Cool.
Okay, perfect. But will you still writing next semester only, eh?
Yeah, I saw, but I just
Okay,
want to
cool.
be ahead of
No, no,
time,
no, just perfect.
Oh,
No,
oh, okay.
100%. So I'll send you a few packs of
Oh,
other things. Cool.
okay. Cool.
Okay. Okay, so let's look at this one. So first, it is one that you need to decide: is it a combination or is it permutation? So that is nearly one of the first things to decide um, which one it is: combination or permutation. So let's quickly read. Find the number of ways a chairman, a vice chairman, a secretary, and a treasurer can be chosen from a committee of 8 members. Okay, so this is the first time, I think, in the last 2 or 3 um, sessions that we actually have a permutation. So they clearly say here, find the number of ways a chairman, vice chairman, secretary, and treasurer. So there's definitely ranking in this. So order matters, can be chosen from a committee of 8 members. Okay, so we've got n equal to 8. Then on our calculators or in the formula, when we look at it, we know what R is. R is 1, 2, 3, 4. I want to see if I haven't missed anything else. So R is 4. So for the permutation, and now again, some of the calculators differ. And let's hopefully I can get it right on mine. Sure. Okay, I get, this feels very big, 1,680. So N8 permutation of 4. Okay, 1680. Okay, that is a lot of, and So, sure. That's now. Okay, so let's quickly. So on my calculator, it was 8P4. Let's quickly. Where did I put a formula sheet? So formula sheet, there is a permutation. So the permutation from the formula sheet is okay, so let's quickly write what that means. So n factorial, n is 8. So it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that is what n factorial. So we know n is 8. So that's what n factorial is. At the bottom, n is 8, r is 4. So let me quickly write that in. So we would have set 8 factorial divided by n minus, so 8 minus 4. So then 4 factorial is 4 times 3 times 2 times 1. Okay, at the top and the bottom can cancel out the 2 1s, the 2 2s, the 2 3s, the 2 4s. So what I'm left with for the answer is 8 times 7 times 6 times 5. And that is supposed to give me the same 1680. The reason permutation is because there's an order in chairman, vice chairman, secretary, and treasurer. So nearly the same to say somebody is 1, 2, 3, and 4. So it matters in what position the person is. So that is why it's a permutation and not a combination. Combination basically means I don't care if Vuyu is first and John is second, or if John is second and Vuyu is first. It sees it as the same combination because me and him is in the same grouping. So yeah, it matters. Yeah, it matters if somebody is the chairman, then the vice president, vice chair, secretary, and treasurer, and for combinations of how they can be selected. Okay, so and remember, there's 4 positions and 8 people, so it might be that I'm chairman for all 8 times, that for the first time that everybody is selected nearly, and that process continues for all the other people as well. So the important thing with permutation is that there is some kind of order or ranking. So permutations most often happens in, if I say there's 10 athletes, the first three is first, second, or gets gold, silver, bronze. How many permutations is possible for that to happen in that 1, 2, and 3? So that is certain things. So permutations normally is asked when there's nearly a ranking possibility. Okay, does that help a bit to see how to get to that 1680?
Yes, thank you, sir.
Cool. Okay, so now let's see this one. A Senate investigation committee of 4 members, there's still 4 members, is selected from a Senate committee of 10 members. Okay, so now I would have loved it if they also said 8, but okay, so 10 members. So here we, doesn't matter if selected 1, 2, 3, 4. So here there's no, we're just selecting 4 members. Okay, so here's no reason for order. There's no order in this. So this would have been a combination where out of 10, we are looking for a combination of 4. Okay, so if it was 8, I would automatically have said it needs to be less. Combinations is always less than permutations, but let me first see what it is when we increase now to 10. Okay, so I get my answer as 210 according to the calculator, but let's also write that down as a formula. So the formula would have been n divided by n minus r factorial times r factorial. Okay, so let's just do that. So you can see at the top, n factorial is 10. So let's multiply that out. We're not going to multiply all out. We will be able to cancel a few out. So don't worry that we now need to multiply that out. There's also, on most of your calculators, you will sometimes see a n factorial button as well. So normally close to the combination and permutation button, there is sometimes an n factorial button as well. Okay, so n minus r was 4, so n minus r is 6. So let's do the 6 factorial. And let's just see then 4 factorial. Let's add that because that is part of what we need to divide by. Okay, so let's start with n to 2, that cancels out. Over 1 doesn't matter. So 2 goes into 6 3 times. 3 goes into 3 1 time. So there's that 5 that at least is left. There's a 5 that we can cancel the 5 out. So that is also gone. So we're left with the 4. 4 goes into 8 twice. and then there's a 6, so 2 goes into 2 once, 2 goes into 6 3 times, 3 goes into there once, 3 goes into there 3 times. So let's see what we're left with. We're left with 10 times 3 is 30, times 7 is 210. Okay, so by using the calculator, by using your formula, you will get the same answer. Okay, so if your calculator don't have that that function, at least you can also have do it with a formula. Okay, so this one, it doesn't matter which way the 4 people are selected, because there is no reason why, or no order. We can say it is a combination. Okay, so what you can also remember is, if it is the same number for permutation and combination, permutation is always bigger. Okay, so if, and that's why when I looked at the previous one, I was like, okay, if my answer for this one was 1680, and that was 8 members, then I know, okay, 1680, it must be more than, so I would have cancelled out 2 of the answers already, because I know that combination much less than permutation. Okay, so and we've now nearly shown it that even if you increase the number n bigger, you still get that your combination is much less than your permutations. Okay, so combination, permutation, and then a type of ratio question. So a packet of 160 sweets contains red, blue, and yellow sweets in the ratio 3:3. Which one is the correct one? Okay, so just looking at 3:3, it's nearly to say, okay, let's just put that's red, blue, yellow. So 3:3, so I know I must have the same number of red and yellows. So it doesn't even matter yet working out. So red and yellow must be the same. Okay, red 40, yellow 40. Okay, so might be red, yellow. Okay, might be red, yellow. Okay, not the same. Can't be red, yellow. Must be the same. Can't be. Okay, so without even looking at numbers yet, we just nearly eliminated things. Now, the next one is to say, well, 3:3. So that tells me I've got less blue than red or yellow. So that blue is more, it's more, so can't be. Red, blue is less. So by not even working out anything, I nearly got to what it's supposed to be. But let's still work it out so that you know if it changes. So how many numbers do I have? It's 3 plus 2 is 5, plus 3 is 8. So my ratio is, for red, it's 3/8 times 160. For, sorry, that should not have happened. For blue, there's 2/8 times 160. And then for the yellow, again, there's 3 of them, 3/8 times 160. Okay, so that is how we would have worked out how many numbers there are. So 3/8 times 160 is 60. 2/8 times 160 is 40. And if we add all of them together again, we also will get back 160. Okay, so 60 red, 40 blue, 60 yellow. Okay, but you can also nearly, sometimes if it is nice numbers, reason it out a bit. If it is now a quarter and a third and a sixth, then rather just try to get to numbers when try to make it reason it out or anything like that. Just, again, I hate when those things are fractions. I just don't like fractions at all with these kind of questions. Okay, another type of ratio question. So if a diagram above is PQ, so let's just make it, sorry, a bit bigger. Okay, so here we have PQ. If a diagram above, if PQ is 45 millimeters. Okay, so that whole line is 45 millimeters. And the ratio of TQ to PQ is 2 to 3. Okay, that's interesting. So TQ to PQ is 2 to 3. I'm just writing it a bit like that so that we can check it out. Calculate the length of PT and TQ. Okay, so let's first look at some of these answers. So we know that length is 45. Okay, so nothing can change there that it now suddenly is becoming shorter or longer. So if PT is 20 and TQ is 30, that will be 50. Okay, and we only be able to work out 45. So that's definitely not right. If PT is 50, TQ is 20. Okay, so that's also 50. If PT is 15, 50, 45. Okay, so that might be. If PT is 50, TQ is 15, again 45. So that might be. Okay, so in the diagram above, PQ is 45, the ratio TQ to PQ is 2 to 3. Okay, so let's check. So if, and this is now where I quickly want to draw it just a bit differently. Okay. That is PQ. That PQ is for whole thing. Still Q. And this is T. Okay, so now you can see that, okay, if whatever that is, that PQ is longer than TQ. Okay, so whatever this answer is, PQ is longer than TQ. I wonder if this is not a bit wrong. Okay, so PQ, TQ. So if that is 2, that whole thing, what will be the PT? So if that is 45, and I think this was, so that whole thing is 3, that is 2, that is 3, this is 1. So TQ is 2 divided by 3 times 45. 2 divided by 3 times 45. So TQ is 50. TQ is 50. That's the longer one. If that is 50, 2 divided by 3 times 45. Then PT, don't know why we don't do that. PT is 1, so 1 divided by 3 times 45 is 15. Okay. So for me, and I think this should actually be TQ in relation to PQ with 2 over 3. So see it as nearly as to write it like that. I think that is, and I don't like, so that's why I nearly wanted to redraw the line, because it's sometimes difficult when you're working with the same line and need to cut it up to nearly also work with it to see some of the implications, or need to see what it gets to. Okay. So again, we're doing a bit different questions tonight, but I think it's good that we see some other questions to previous Okay, so here is another one. So the sketch above shows a rectangle with a frame around it. The frame is the same width all the way around. Okay, so they could have just given us the whole thing. I don't know why they cut that off. The picture is 25 and 30. The total height of the picture and the frame is 40. Okay, so what they mean is that width, that width, that one, and that is all the same. Okay, so if we know that that is 50, if we know that this whole thing is 40, that must be 5 plus 50 plus 5 to get us the 40. So because it's the same, that will also be 5. That will also be 5. So we know that the total length here would be 40 centimeters because that's what we're given. But the total width there will be 5 plus 25 plus 5, which is 35. Okay, so that is nearly, when they ask us, calculate the area of the frame without the picture. So basically what they want us to work out is the frame. So what we will do is we will work out the total area of the orange, which is length times breadth or height times width or whatever. And then we're going to say, but let's take out this area, the pink, which again is L times B. So if we subtract those two, we will get what the black area is. So when we subtract those two, we will get to the black area. So let's L times B. So we've got the outside 35 times 40. So the orange whole area is 35 times 40, which is 1400. The pink area, the picture frame, that is 25 times 50. Which is 750. And then if we subtract the two, we get what is left over. So 1400 minus 750. So the part that is left over is 650, which is your option 1. Okay, so a bit different type of question where they could have also just said, like they do normally, they could have said just color that frame in and say work out the area of a colored in area. But that's normally what they would do. So this was now asked a bit differently, so that they nearly ask you to work out what the width is and those kind of things as well.
Sir. Sir.
Hi.
Can I ask?
Yes.
I don't understand how did you get you end up having 35 as your
Okay. So let's quickly. So they tell us here, the frame is the same width all the way around. Okay, so let's take that out. So I know that this length is 40 centimeters because that's given. They also said it to me here in that it's 40. They tell me that the height of the picture is 50. Okay, so if I say 40 minus 50, I get that I am left with 10 centimeters. Okay, so my frame in total is going to be 10 centimeters thick. Okay, but I've got the frame on this side to get to that 10 and on this side to get to that 10. And they told me that it's the same width all the way around. So if I say, well, that piece plus that piece must give me 10. If I divide it by 2, I get that that component is 5 and this component is 5. So, and because that is 5, again, they told us the width is all the way around 5. That component is also 5. That is also 5. So then if I want to get the outside of the frame, it is 5 plus this 25 plus that 5 again. So 5 plus 25 plus 5 will give us 35 for outside. Okay, does that make a bit more sense? So very careful in reading what they give you. So by nearly saying that the width all around is the same, that nearly triggered that. If they don't give you that specific information, then it could have been 3 and 7, 4, 6. Then I wouldn't have known what, I just would have known the two components together is 10, but they need to tell me that it is exactly the same size. Okay, so they need to at least give me some indication of how I need to get to that. Otherwise, again, I would not be able to do it if I don't. Okay, so let's look at the next one. Okay, so a rectangular tank. Now again, I need to get my English right. Long, width, deep. Okay, so we will probably have something like that. So I must not do a, okay, so 5 meter long, 4 meter wide, 3 meter deep. Suppose water is pumped into the tank, not bank, at a rate of 8,500 liters per hour. After 4 hours, what is the level of water from the top of a tank? Wow. Okay. So first thing, let's work out how many liters this thing takes. Okay, so work out volume, length times breadth times height. So we've got length times breadth times height, and that is 5 times 4 times 3, which is 600 centimeter to the power of 3. Okay, so if we have 600 centimeter, sorry, all this in meters. Let me just make 100% sure. Got meters, meter, meter. Okay, so we've got 600 meter to a power of 3. How many liters is that?
Sir,
Yes.
I think you made a mistake. It's not 600, it's 60.
Ah, thank you very much. I must get better spectacles for me. Sure, I can't even read on my. Thank you for that. I can't even read on my calculator, and it does say 60. Okay, 60 cubic meters. So cubic meters to liters, how much is that? Okay, so 60 cubic meters is, do you guys get 60 times 1,000 to get you 60,000 liters? Is that, did you guys get that as well? Okay, so if I said the rate is 8,500 liters per hour, after 4 hours, there would have been 8,500 times 4, 8,500 times 4. That gives us 34,000. So this is quite a. So if I want to know how much is filled, I know this whole tank takes 600 liters. If it pumped 4 hours at 8,500, there was 34 liters pumped in 4 hours out of a total of 60,000 that the pool can take. So that is how much it's filled. If I want to know how many meters, I know that the length or the height, sorry, is 3 meters deep. So that fraction times 3 will give me how many liters or how many meters it has filled up. Okay, so 34 divided by 60,000 is 0.5667 times 3 gives me 1.7. Okay, so it has filled up to a point that is 1.7. And so that's what's filled up to a point that is 1.7. So what's filled up is 1.7 meters. Okay, so that is filled up. What do they say? After 4 hours, what is the level of water from the top of the tank? Yeah. So filled up is
Sir,
1.7. Yes.
sorry, can I cut you just there? I think I lost you where you got 1,000. I'm very lost in that part.
Okay,
I know
so
where 60 is coming from, but I
okay,
don't know where the 1,000,
okay,
where the 1,000.
so you need to convert 60
Mhm.
cubic meters into liters.
Okay.
Okay, so for us to convert meters to liters, we need to multiply by 1,000.
Oh, okay.
So
Okay.
that is where that comes from. So
Okay.
if it was centimeter to the power of 3, we would have divided by 1,000. If it is meter to the power of 3, we will multiply by 1,000. Okay, so
All right.
that is where we got to go from 60 what is it, cubic meters to 60,000 liters. Okay, so we multiply it by 1,000 because, and how you can look at it is for nearly each one of these. So it is each meter, there's 3 of them, but it's actually 10 times 10 times 10. Okay, so that is because it's to the power of 3. It's 60 times 1,000. Okay, so that is from converting from the meters or the cubic meters to liters. Then why do we multiply by 3? Because they ask us that we need to check on that depth level. Okay, so we know that the total depth is 3 meters. So that's why I multiplied by 3 is to say, but how far is it on that 3 meter line nearly? And what we've worked out is how far it is from the bottom, how much it is covered, which is 1.7 if we work it out. But again, nearly trying to trick us because they ask us what is the level of the water from the top of a tank. So if it's 1.7 from the bottom, the tank is 3 meters deep. What is actually left from the top, it is 1.3. So this was really a tricky one. So again, I did not realize when I took this, was a previous exam actually, it was really difficult questions. So, but it's way back. So it will definitely be more combination of all the questions that we had. But yeah, so I nearly first worked out how many water will flow into the tank over 4 hours. So how many water would flow into a tank? So if 8,500 flows in an hour, in 4 hours, it will be 34,000. So the tank was 34,000 liters full. I know the total capacity of a tank is 60,000. So then I know how much nearly of that has been completed. Okay, so we could have, you could have done it a bit differently as well to say, well, that is a percentage that have been filled. So I can look at nearly that depth of a percentage, how much is that, or the portion that is not filled, um, times the depth and the depth, and work that out. But yeah, I think this was um, quite a difficult one because and one can see this was questions that was also pre-COVID, where you would get marks for other things as well. So now that it's multiple choice, this was also multiple choice, but then you still handed it in with all your workings. Here they don't know what your workings is. So here you needed to work out the tank for whole volume. Then you needed to, from volume, needed to go to liters. So that's another step. Then you needed to work out how much water filled in. Then you needed to work out a percentage. And then even with that percentage, where there is an answer, you still needed to say, but hang on, I don't want the water that filled, I want the other level. So yeah, a lot of work into this one question for you nearly to work out. Okay, so let's look at the last one for tonight, and then tomorrow night we'll end off your last prep, and then at least you've got Wednesday to do more practice and go through some of the videos and presentations. Okay, so let's look at what I ask with this one. Find for volume. This seems like a better one. Okay, not as easy. In millimeters of a cube with side of 3 centimeter each. Okay, so cube 3 centimeter each. So first need to convert into from centimeter to millimeter, and please do it before and not afterwards, because then it really becomes difficult. So 3 centimeter is 50 millimeter. Okay, so now it actually becomes 50 times 50 times 50, which is 27,000 millimeters to a power of 3. Okay, if we just said 3 times 3 times 3, we would have gotten 27. But it is 50 times 50 times 50, which gives us the 29. Okay, so first convert from centimeters to millimeter, because what they could have given you as options is, instead of this, they could have given you 270, because we normally convert and say, well, 3 centimeter is 50 millimeters. So sometimes they want you to make that mistake to say, well, now we've got the 27 millimeters, but oh yeah, we need to convert. So we add a 0, but actually we need to add 3 zeros. So it's not just the 1 0 to convert it from centimeters to millimeters, because there's 3 sides, it's the 3 zeros. So that's sometimes why they would give you the 27, because if you just worked with the 3 threes, but sometimes they give you also an option of just taking that 27 and add the extra 0, because that's normally, if we only look at one side, what we would have done. So just be careful that we don't give that as an option, where you from the start, please convert from centimeters into meters, into millimeters, because it just, if you want to do it at the end, you need to remember that there's actually 3 zeros that we need to add, and not just 1 as we would have done if we only were looking at one side. Okay, so that is it for tonight, everyone. So what I will do, and let's stop the recording when I can put it onto the WhatsApp group a bit earlier. So if you not on the